Good afternoon, and thank you for joining us today for this media briefing on the upcoming launch of METOP second generation and Copernicus Sentinel-5, which will be launching on Ariane 6 this August. Before we introduce our expert panelists, some admin remarks for the members of the media who are joining us today. You will have the opportunity to ask questions once we're done with the opening remarks, and please make sure that you type the question into the chat field on the right side. And please state your name and media outlet, as some of our panelists may not know you. And there will be experts also joining who are in the attendees. Joining us today, just I'll give you a list of everyone that'll be speaking, and I'll put it in the chat as well, so you have all the names correct. We have Phil Evans, Director General of Eumetsat, Simonetta Cheli, Director of Earth Observation Programs at the European Space Agency, Katerina Bamps, Policy Officer for the Earth Observation Unit at the European Commission, Selma Cercelli, Head of Earth Observation Program at CNES, Gadela Rosner, Head of Earth Observation Department at the DLR, and Simon Brown, Managing Director for Products and Services at the Met Office. Now, without further ado, I'll let Phil Evans start off by telling us a bit more about these missions. Thank you very much.
Good morning, everyone, and thanks for joining us. It's a great pleasure to be opening the media session this afternoon for the launch of MetOp-SG-A1 with the Copernicus Sentinel-5 mission. As you'll understand, it's an incredibly exciting time for Eumetsat, for all our partners in this, for ESA, for the industrial contributors, for the user community. It's an incredibly exciting time. So I think before I talk a little bit, give a little bit of an overview of the mission, I think it would be useful to set the context a little bit. Next slide, please. And that's really to understand the impact of severe weather events on Europe and how that is changing. In the context of climate change, Europe is warming twice as fast as the global average. That makes it the fastest warming continent in the world. And along with that, severe weather events are already a major problem, but we're likely to see an increase in frequency and intensity of severe weather events. And that's where weather forecasting plays such a vital role and such an important role for societies in Europe. If you look at, the impacts of severe weather are enormous. If you look at heat-related deaths, for example, which are the biggest cause of reported deaths in Europe related to meteorology, there were nearly 50,000 heat-related deaths in Europe in 2023. If you look at the economic losses of weather and severe weather events between 1980 and 2023, over 700 billion of economic impacts of climate-related and severe weather events. And particularly relevant, as I'll tell you about in a moment, to this mission, is also the impact of poor air quality. Although air quality in Europe has improved greatly over recent years, it is still the cause of a huge number of premature deaths. Estimates, for example, say that in 2022, air pollution caused premature deaths of over 350,000 people in Europe. And that's very relevant to this mission, as I'll come back to. Next slide, please. So what is this? This is the first launch of our next generation of low Earth orbit satellites, METOP, second generation A1. And next year, hopefully, we'll be launching A2. This is as I said, a remarkably exciting moment for us. The previous METOP mission, METOP first generation, actually was the biggest contributor in the world to the reduction in forecast errors, reduced those by 25%. And we're expecting this new advanced version of METOP to continue and potentially improve that. Not only is it relevant to numerical weather prediction, a numerical weather prediction is the mechanism by which the community provides forecasts, and METOP-SG-A1 will be crucial to weather forecasts from 12 hours ahead to 10 days ahead. But it's important for climate monitoring, and it's important for nowcasting, which is very short period forecasting. Now the satellite has got a suite of extremely complex and innovative instruments that are complementary to each other, that work in unison and work with the instruments on the other platform that we'll be launching next year to provide a wealth of valuable data to our user community. So to quickly go through the instruments, we've got IASI Next Generation, which is provided by CNES. And this is really a development of the existing IASI instrument, which is the global reference standard for temperature and humidity measurements. We've got the microwave sounder. We've got METimage provided by DLR, which again continues the heritage of AVHRR and provides high resolution imagery that will be hugely valuable for NWP. Radio occultation sounder, and the multi-viewing, multi-channel, multi-polarization imager. Try saying that quickly. Which is the first operational polarimer to fly in Europe. And last but in no ways least is the Copernicus Sentinel-5 mission that measures a range of trace gases in the atmosphere, methane, carbon monoxide, nitrogen dioxide, sulfur dioxide, and will provide really important information to improve air quality forecasts, which, as I've already illustrated, is a major issue. And all of this, as I said, will be complementary to the next mission that's launched, METOP-SG-A1, but also complementary to the data from our geostationary satellites, the second one of which we've launched quite recently. Next slide, please. So this, and it's not an exaggeration to say it's a masterpiece of European technology. It's also a masterpiece of European collaboration. As I've already said, the collaboration between ESA and industry, DLR and CNES is fundamental to this. This satellite will deliver a cost-benefit return of 20 to 1, which is enormous. As I've already said, previous missions reduced the errors in NWP by 25%. It's the first European contribution to the Joint Polar System, which is a collaboration with the USA where we jointly operate a polar system together. As I said, we're flying Sentinel-5 on this, which is the first hosted Copernicus Sentinel mission in low Earth orbit. Again, that maximizes synergy between instruments, and also it's a very cost-effective way of launching satellites. And as I said, this is a huge collaborative endeavor involving 17 countries and 110 companies. Next slide, please. So, what are the applications of this? Well, they're remarkably wide. I've already mentioned numerical weather prediction, which is the fundamental way in which weather forecasts are produced. Nowcasting, very short range forecasting, but also have a huge amount of benefit to oceanography, hydrology, atmospheric composition and air quality, and climate monitoring. And as time goes on, as the scientists and the user communities find ways of exploiting this data, we will find more value to extract from it. As I've already said, there's huge benefits in the synergies between the instruments on this platform and synergies between the METOP-SG-B platform and also between the geostationary satellites. And just to say, we launched a second geostationary satellite a few weeks ago. That's now safely in orbit and about to undergo extensive testing and calibration. So we're poised for another pivotal moment for the European meteorological community and space community, with a launch scheduled for the 12th of August. We're greatly looking forward to what will be another major step change for forecasting in Europe. Thank you very much.
Thank you very much, Phil. I'll now hand over to Simonetta Cheli, Director of Earth Observation Programs for the European Space Agency.
Thank you, Adelina. Good afternoon to all of you. As we just heard, this is a fantastic and exciting mission. It's a mission of strong collaboration between Eumetsat, the European Commission, ESA, but also member states. So we work on this one with DLR and with CNES, and you'll hear all about it. I mean, It's a mission which is the second generation of METOP. We started METOP together with Eumetsat in 2006, and here we're going to the next generation. And if we go to the next slide, we see how this fits in our, frame of all the remit of our Earth observation program, which is quite vast. So if we go to the next slide, we see that in ESA we developed in the context of the Earth observation programs 3 lines of activities. One is the meteorological mission jointly with Eumetsat, and METOP second generation is part of those missions. One with the Commission, which is the Copernicus Sentinel satellites, and the other one is the scientific missions, which are the Explorer ones. And this is really part of the strong collaboration, the longest one that we have with Eumetsat since the 70s. In fact, we have developed next generation meteorological mission, procured those for Eumetsat, and developed and co-funded the first generation. This is METOP second generation is part of that, and it's actually also complementary to what we recently launched with MTG Sounder mission early July. If we go to the next slide, we see really what's the remit of this mission. As you heard from Phil, this mission is enhancing weather prediction, is improving the forecast, it's improving nowcasting, and it's also improving climate information. And how is it doing it? It's doing it with, I would say, continuity of measurements, continuity on what we have done until now with METOP, but also with enhance and evolve the instruments on board the satellites. The satellites are 6 overall, so they're 3 successive pairs, A and B. Here we have the first A of the first A mission in terms of the first pair. And we have a combination of those satellites, which overall will provide data for the continuity in terms of users for about 21 years. These are satellites that will last in terms of initial lifetime 7.5 years. They're satellites that will provide 24 hours information on the globe every 24 hours. And they're satellites which are turning in polar orbit. So they're very complementary to the ones which are turning in geostationary orbit like MTG Sounder. Those satellites have about 10 instruments on board between the A and B within the pairs. And those instruments are quite a variety of instruments in terms of, we heard the microwave sounder, in terms of meteorological imager, also radio occultation sounder, multi-viewing, multi-channel, multi-polarization imager, and also, last but not least, Copernicus Sentinel-5 instrument. It's satellites which also have quite a novelty, I must say, a novelty in terms of controlled re-entry that is planned for those satellites at the end of life to reduce everything that's related to space debris. In fact, about 2/3 of the propellant on board these satellites, which are about 4,000 kilos overall, it's devoted to organize a controlled re-entry at the end of the lifetime. If we go to the next slide, we see also that on top of the instruments, which are really the meteorological ones, where I mentioned in particular, the one on multi-viewing, multi-channel, multi-polarization imager, which gives data on atmospheric aerosols, we have the Sentinel-5 instrument, which is part of the Copernicus family. It had a predecessor on board, the Sentinel-5P mission, which was really preparing for the full operational fledge of this Sentinel-5. And Sentinel-5 is in fact having an ultraviolet visible infrared image spectrometer, which is really going to provide quite important information about everything that's related to gases. In particular, we'll have information on ozone, on nitrogen dioxide, on sulfur dioxide, formaldehyde, and carbon monoxide and methane, as well as aerosols. So very, very relevant information for our daily lives in terms of looking at air quality. And you know that there are about 7 million people that die every year due to bad air quality. So this information, complementary to the meteorological one that we'll get from MetOp-SG, is going to be essential to support also operational services in that context. If we go to the next slide, we see also that this is not just a collaboration among institutions. It's really a very strong collaboration with industry and with industry support. In fact, this is also part of really the work that ESA is implementing, the contractual setup, the procurement for those satellites development. We do it for the first generation as METOP second generation is, but we also do it for operational system on behalf of Eumetsat. And here, in the case of METOP second generation, Airbus France was the prime contractor, has been the prime contractor for the development of the satellite. We actually even had the chance recently with the press to be in Toulouse to see the satellite before it was shipped to Kourou for launches. It involves more than 110 companies, and this you see is quite challenging in terms of organizing the industrial work, the subcontractor role, and 16 countries with Canada also being also associate country to ESA and cooperating state. We have over 280 subcontractors, and we have about 2,500 people involved on the industrial side. So this is really a very strong industrial endeavor on the MetOp-SG side, but also on the Sentinel-5 side. We have connected with us today the two project manager for MetOp-SG, Marc Loiset, for Sentinel-5, Didier Martin. They've been really organizing this strong industrial work and leading, all the work in terms of challenging industrial developments, technology developments to arrive to today. On the Sentinel-5, Airbus Germany has been the prime contractor. We had a leading consortium of about 25 companies involved with 15 countries and 50 subcontractors. So a lot of people also on the Sentinel-5 involved, about 500 people on the industrial side. And if we go to the next one, I'm not sure what's the last one, it's over, but just to stress that we're looking forward to the launch. We just had today confirmation about the target launch date from Arianespace, and please follow us during the next days for the launch campaign completion and up to launch. Thanks.
Thank you very much, Simonetta. And I just want to remind our journalists who are joining us who might not have seen that the slides will be made available at the end of this briefing, so you will get a chance to review them. And now over to Katerina Vance from the European Commission.
Yes, good afternoon, everybody. You can hear me well? That's okay?
Can hear you well.
Okay, thank you. The European Commission shares the excitement expressed so well by ESA and Eumetsat, and I would like to copycat Phil a bit. And looking at the slides and the presentations, it's a true masterpiece of European collaboration. Thank you very much for that. I'm here at the European Commission. I'm here on the Sentinel-5 instrument. It is piggybacking on this Eumetsat satellite that is already also, as Phil indicated, it's cost effective and also reduces the carbon footprint. So for Copernicus, the European Commission is the program manager and works closely together with its member states and the Copernicus participating states, and obviously also with all what we call interested entities that implement the Copernicus program. But let's talk business very quickly. Have a look. So if you look at the report that was produced by our European Union Space Agency, European Union Agency for the Space Program, apologies, we see there that they analyzed, and there's the global market for Earth observation data and services, the downstream sector. And if you look at the different market segments where revenues are being produced, so what the companies or what the business operations are producing using Earth observation, you see that the estimation already, the calculation in 2023 was already in a revenue of 3.4 billion euros. And the estimation is that by 2033, it will double. This is what is being done at the level of the downstream sector. Now, if you are here as a journalist and you ask yourself, okay, but what is the cost of the Copernicus program and does it make sense? So in the midterm review of the space program, a comparison was made with the benefits that it brings to the society, the environment, and the economy. And there's an outnumbering, there's a clear outnumbering. Now, back to the graph that is being presented here, the top 3 segments are here: climate, environment, and biodiversity, agriculture, and urban development and cultural heritage. This is where the information applications, the value-added services are currently ramping up enormously. Coming in is also, like you see, in insurance and finance. This is where business applications are really truly being developed to serve the user. Think about an application to monitor air quality, for example. Let's go maybe to the next slide. If you didn't know by now, Copernicus is Europe's eyes on Earth. I mean, this is a world-leading program and most advanced Earth observation system. And I would like to repeat again, it's also an enormous effort of collaboration, because we have our EU member states and Copernicus participating states together with us, interacting with us, and it's a close collaboration. The Copernicus data and the information from the 6 Copernicus services are provided for on a full, free, and open basis. You have enormous amounts of data that are being provided daily. And currently we're very proud to say that there are 10 operational Sentinel satellites in orbit flying. And so with Sentinel-5 being successfully launched on the 12th of August, we will have a full football team, 11 operational Sentinel satellites at one point in time. We will be able, hopefully, to say that. So the image that you see here is an example of the emergency management service that captured the flooding in Valencia. Next slide, please. So why Copernicus Sentinel-5? As you know, already Sentinel-5P is in orbit, functioning very well, going over, exceeding expectations. Actually, that's what I understood from my colleague Maria Berdal, who is the expert. And Sentinel-5A is the operational successor. What it will do is that every 100 minutes, it will orbit the Earth from pole to pole, and it will deliver daily global data on air pollutants and other atmospheric trace gases. So, thinking back, we had already a successful launch of Sentinel-4, now Sentinel-5 coming in, Sentinel-5P5, and the upcoming 2027 CO2 mission that will make sure that will secure the capacity, the European capacity, Copernicus capacity, and making it even a stronger world leader regarding atmospheric monitoring. Yes, Simon, my colleague is sharing here the slides. Thank you, Simon. Enhanced capabilities for Copernicus. The Sentinel-5 instrument will perform atmospheric measurements at a high spatial, spectral, and temporal resolution on trace gases. And so what you see here below is the representation of the emissions. And like Phil was saying, it's about nowcasting, forecasting also here. And this is to show that we will be able, or we are already able, to trace this, and this is to monitor the air quality, but also the pollution, solar energy, and to assess what is going on with climate and climate change. Next slide. It benefits the user. So you might think, okay, where can I find these data? You can onboard or try to register. It's an easy progress into the process in the Copernicus data space ecosystem. But obviously, these data are also going to be used to transform them into an information product by our Copernicus Atmosphere Monitoring Service and our Copernicus Climate Change Service. It will help our full Copernicus user community. You can go back, sorry. That includes environment agencies, public authorities, our scientific users, of course, to monitor air quality, pollution, climate change, and to support related decision-making. And I would like to say evidence-based decision-making. The image that you see here is the plumes from the volcano eruption in Indonesia in 2024. And here you see how important it is for the air quality for the people that are living there, but also for safety for air traffic. They need to be able to monitor these plumes. Next slide. And so Sentinel-5 data will also be introduced in the CAMS models so that they can even provide a even more powerful tool for tracking pollution sources, the quantification of these pollution, forecasting air quality trends, and supporting the EU environmental health policies like there are the EU methane strategy and the zero pollution action plan. Okay, next slide. And I think that's the last slide that we're showing, yeah. Ensuring the widest Copernicus uptake, and here you see, of course, the key elements, the most important elements that are in place. And I like to highlight the Copernicus user forums where we work together with our delegates. They define the user requirements. They're very active. They are they are closely linked with their own public authorities. We have the scientists and the researchers in the Horizon Europe projects. We have the EU Space Support Office with the EU Space Networks. We have the Cassini Entrepreneurship Initiative, and of course the CDSE. And so we're absolutely excited and looking forward to the successful launch of the 12th on the 12th of August. And like I said, we hope that by then it will be successful and we will have a football team, a Copernicus football team. 11 Sentinels will then be flying. Thank you very much.
Thank you very much, Katerina. And now for a sort of deep dive into some of the instruments, I hand over to Selma Cheli from the CNES. Thank you.
Yeah, thank you, Adelina. Good afternoon. As mentioned, I think it's really a fantastic moment. It's a fantastic moment because it's an illustration of the European leadership when they could bring together all the European expertise at different levels. I will speak about the instrument, but before I would like to say that this expertise is relying on different folds. Science, user needs, as mentioned by the European Commission, but also the excellence and expertise and know-how of our European industry, which is quite important when linking all those together. It becomes to this really a cutting-edge mission with a very ambitious objective that were mentioned. So on CNES side, of course, in the frame of cooperation agreement we have with our Eumetsat partners and others, CNES is in charge of development and delivery of IASI new generation instrument contract by Airbus Defence and Space in France as a prime instrument, but also in charge of the level 1 data ground segment processing and technical expertise center for the in-orbit performances monitoring. This is quite important because with IASI new generation, this future of the infrared sounding is ensured as the same scientific and operational goals that has been also developed with IASI success story, which has had a huge impact on the quality of weather forecast and has also led to hundreds of scientific publications. Because there is no weather prediction improvement with such accuracy without relying on the best state of art of science. And in France, we have then more than 10 French laboratories involved in IASI and IASI Next Generation projects. And the data produced by the IASI Next Generation mission fits into not only Météo France atmospheric model, but some of the data are already assimilated by the European ECMWF and are used to develop the better weather forecast. In addition, it was mentioned that also it provides a better understanding of the chemical composition of the different layers of the atmosphere and enable the monitoring of pollens. Today with IASI, more than 27 atmospheric species are currently observed by IASI in near real time. And some of them are now routinely assimilated as CMWF. This is quite important improvement. And thanks to its longevity, the mission has also application for climate on a larger scale. With the first METOP satellite and IASI on board, which was launched in 2006, we have accumulated 20 years of data that can be compared with that which will be soon provided by the new generation instrument. And this continuity of measurements helps to improve the robustness of climate models over the long time. In the framework today of the international cooperation, this is something really important because 13 out of 16 of essential climate variables today for atmosphere are already observed simultaneously with IASI. And with this new generation of instruments, we will really improve by a factor of 4 the accuracy of the measurement already provided by IASI, thanks to the ability of the science community on our side and at European side to provide us with the feedback and all lessons learned during these 15 years of continuity measurement from IASI. The fact that IASI has been the global reference instrument for over 15 years, thanks to the quality and stability of the data. So in summary, I think the enhanced instrument, enhanced science, responding to all the users' needs that already has been presented by the European Commission, Eumetsat, it's really today opening a new era in terms of improving the precision of the retrievals to allow the detection of new species, not only the ones already retrieved by IASI. And thanks also to the really fruitful cooperation and collaboration between CNES and Eumetsat, there will be probably and surely and certainly an improved in terms of performances. Last but not least, of course, the IASI-NG observations are key, but we have in front of us also the opportunity to develop a new way in order to use those capabilities with other instruments and other data on board METOP. And with the, of course, 3MI that has already mentioned, where there is a strong also CNES expertise in that instrument, there will be also a new development, novel methods in order to use in synergies all those data that would be provided, of course, by this mission. So again, we are looking forward for this new generation, new capabilities. Of course, recognize the French expertise in infrared sounding, thanks to the science community, but also to all industry capabilities that we have at European level. Thank you very much.
Thank you very much, Selma. And now over to the DLR, also for another deep dive, and to Gudela Rossner. Thank you.
Yes, thank you very much, and good afternoon to everyone. I can just repeat that it's really a big joy and an excitement to be so close in advance of the launch of METOP second generation. And it's also an honor to be part of this really strong cooperation between all the partners, Eumetsat, ESA, the European Commission, and other agencies like CNES, and of course industry. And we're very proud to deliver the METimage instrument as a piece of German technology to contribute to this European weather observation system. Yes, and I would like to give you some more details on this instrument, as it really is a huge step forward in improving weather observation, as this piece of technology is the successor of the AVHRR instrument. But with METimage, we will reach a much better resolution in the sense of spectral channels, but also in the sense of spatial resolution. And with this, deliver high precision data on what is really needed in terms of observation of clouds, water vapor, aerosols, land and surface temperature, ice cover, vegetation, and fires. and describe the improvement. Instead of having 6 spectral channels so far, METimage will deliver the data in 20 channels between the visible infrared and infrared channels. So really going into much more detail and having a resolution of 500 meters instead of 1 kilometer. And this in the daily coverage that the satellite is providing. So with this, we're really aiming to have better insight in the processes of the weather and providing better information, better data for numerical weather prediction, but also especially in the nowcasting information that was mentioned before. So really delivering information that comes 2 or 6 hours before the event is taking place. And this we will expect will help tremendously in warnings with respect to heavy events of storms, or other extreme events, as one aspect. Another one will be also to have a monitoring of the global wind fields, and with this also contribute to the understanding of the processes worldwide and on a global scale, also covering the polar regions. That wasn't possible before. And with this also helping to improve our understanding of and prediction of the weather, improving weather forecasting, and also, of course, in the longer run, improving much more the climate monitoring and climate understanding of our planet. The METimage instrument has been mainly, or the development of the METimage instrument has been mainly funded by the Ministry of Transport in Germany. DLR has taken the program management for the instrument. It was built by Airbus. The development of the 2 instruments for the following satellites then will be financed by Eumetsat. So also there we have a strong collaboration on this instrument, putting it into place. And with this, I will close my talk. Thank you.
Thank you very much, Gadela. And now, last but certainly not least, Simon Brown, representing the user community in the Met Office.
Hello, I will start talking before Steve gets the slides up. Welcome and good afternoon. I'm Simon Brown from the UK Met Office. The UK Met Office are one of many meteorological providers across Europe and of course the world, and we provide weather and climate services for UK government, business and industry, and my role is Managing Director of Products and Services, so very much interfacing with our users who range from aviation, sports, government, other transport, space weather, etc. But the most exciting part of my job is I am one of the council members at Eumetsat, which is made up of 30 members, and I am the UK head of delegation who sits on Eumetsat Council, which meets twice a year. And as other people have spoke today, really, really exciting mission. This is my 4th satellite launch, and I get butterflies every time I go through the excellent science and technology, the input from ESA, the input from industry, and the input from Eumetsat. It's just fundamentally world-leading science and technology capability, which Europe should be very proud of. And this slide really illustrates the importance of this mission. And I have checked, the numbers do add up to 100%. I did that this morning because I'm sure some of the media would point out if they did not. Really what this does demonstrate is 24% of the Met Office forecast accuracy is developed from the EPS mission. And that is huge. And the other bit to point out on this slide is that this is just one mission. There are complementary missions, and Phil Evans mentioned the GEO mission, which was launched only a few weeks ago very successfully. But this really relies on the international community, and the international community, both Europe and the whole of the international community, collaborating to make sure we've got the right satellite measurements in order to serve societal needs to produce the best weather forecasts, particularly given our growing population and growing infrastructure needs, and to help people keep safe and stay safe and thrive. Steve, next slide, please. And I was trying to think about what to say about this mission, and fundamentally the first bit I'm going to say is something a little bit boring. This is all about continuity. Phil mentioned it in his opening gambit. The previous mission led to a 25% reduction in forecast errors, but simply having continuity is really critical. And this is a huge amount of investment, which takes this industry, this community out to 2040, which should not be underestimated, given where we are in terms of climate change and severe weather. So for my scientists back in Met Office HQ to have this data and know we're going to have this data till 2040, this means we can at least maintain our current weather forecast standard, which continues to improve by 1 day per decade. But of course, science and technology moves on, and this data will give us higher resolution data, we'll have more channels, and we'll have greater spatial resolution. So the atmosphere changes. For the moment, it kind of is at the ground to above your head to 1,000 kilometers and even higher in the atmosphere. And we're constantly searching for new data, which fundamentally helps us build better forecasts and weather predictions, both using physical models and emerging AI models, can only be good for society, which has to constantly deal with even more severe weather. And we've seen that this weekend in Turkey hit 50 degrees for the first time. We saw that in Valencia last year. We saw it in Germany 2 years ago. We saw it in Austria last year. We are dealing with more severe weather events across Europe and of course across the world. And then combining the data we get with world-leading supercomputing and weather predictions ultimately allows centres like the Met Office and ECMWF to produce even better forecasts. And previous presenters have mentioned even better in things like nowcasting, thunderstorms, being able to predict precipitation more. Next slide, please, Steve. And as I've already mentioned, this will give us better severe weather warnings, particularly in the high latitude areas. This is really complementary to the geo satellites, which move around the equator. This moves across the poles, so particularly in the higher latitude areas, this will be even better for nowcasting. This will enhance our 10-day weather forecast. It will improve the efficiency for aviation to dodge those thunderstorms, to prevent the risks or mitigate some of the risks of turbulence, to be able to plan their routes so they can be much more fuel efficient. We work with renewable energy, construction, agriculture, and other industries, feed our weather forecasts into them so they can optimise food supply, building materials they're using, and a raft of other industries. For the Met Office, this contributes, or overall, we contribute £19 for every £1 the UK government invests. This mission, as one previous presenter said, returns a 20-to-1 return for society. I will end on a final note, which is users have been absolutely key with this. Users have fed in the requirements of what this mission needs to do. Users have been testing the data. Users will work with Eumetsat on developing new products. And I'll go back to what I said at the start. This mission could not take place without ESA, without industry, without our brilliant scientists, without our brilliant technology and brilliant engineers across Europe. This will allow us to produce better products for society, better products for governments, better products for industry, which ultimately leads to allowing us to help people to stay safe and European economies to thrive for the next 20 years.
Thank you very much, Simon. And that concludes the introductory remarks. And I want to thank all our panelists for sharing this information with us. Now, for the journalists who are joining us, there are two ways you can ask questions. You can either put them in the chat. Please make sure you put your media and your name as well as your questions. You can also raise your hand, and if you do, I will give over the floor to you. You will get a prompt. Please make sure you accept that prompt. That will allow you to unmute yourselves and to ask your question. And make sure that you have headphones if you do so. I know that we have a first question, which I received earlier from Antoine Meunier, La Chronique Spatiale. Antoine, you should have received a prompt to unmute. And I think you can talk now.
Hi, can you hear me?
We can hear you.
Thank you. Well, hello everybody. Thanks for this presentation. In fact, I need two more precision. First, can you remind us the total cost of the mission? And second, it was mentioned that Copernicus deliver Delhi, 25 terabytes of data. So can you tell us what will be the amount of data delivered daily, but specifically by Sentinel-5?
I see Phil has unmuted himself. Phil, please feel free.
Well, I can answer the first question about the cost. Between various contributors, it's somewhat over. It's about 5.2 billion euros. That excludes the Copernicus Sentinel-5 cost. So that's the general cost. I would defer to someone else to answer the question about the data volumes from Sentinel-5.
I can complement Phil maybe on the cost of the satellites. The 6 satellites cost is 2.8 billion euros in 2025 economic condition.
Sorry, how much?
2.8 billion
For 6 satellites.
6 satellites, exactly.
Yes.
So just for clarification, you've got two figures here. You've got the cost of the program, which includes the operational lifetime. So these satellites will be hopefully running out until the early 2040s. So you've got the cost of the program, which includes the satellite costs, which is the figure I gave you, and then you've got the specific space segment costs, which I think is what Simonetta gave you.
Okay, thank you.
Maybe my colleague, because I don't know by heart the cost of Sentinel-5, maybe my colleague can respond on that one.
Yes, hi. I can, yeah. Maybe also Maria Berdel, my colleague, can come in. I don't know if it's possible, but the cost for the development of the satellite stands around 234 million euros. On the question of the data volume, I firstly would like to make a correction. The data will be made available through the CDSE, of course, but also through Eumetsat. So I would like to correct it. Sorry for that. On the amount, exact volume, I think we need to double check on the. It was expressed as a lot of data. I'm not going to use the exact wording, but we will come back. I think it's better that we come back with the exact data volume, so that is correct. Apologies for that, but we will come back on that.
Indeed, thank you very much. What we'll do, Antoine Meunier, is that we will get back to you and put you in touch with the correct entity for that. And I've also actually unmuted your colleague Maria from the European Commission. If there's additional comments, I don't know if that's the case. Otherwise, I will go to the next question. And that question comes from Johan Chabert, Pulsar Spatial. You should have the floor now. Otherwise, I will ask the question for you. Johan, you should have received an invitation to unmute yourself. You can speak now. Unfortunately, I think there's a slight technical problem. I will read your question. After the launch, what is the expected time for getting data and calibration of the instruments? Thank you.
Okay, well, I think I can pick up on that one. So after launch and correctly putting it in orbit and getting the basic platform running, our planning assumption is that it will essentially go operational within about a year. But it's worth bearing in mind that this is an incredibly complicated system. The individual instruments are hugely complex, as you will have understood. The interaction between the instruments and the platform is complex, and then of course you've got all the ground segment, data processing, data distribution. So it's a complicated thing, and this is the first of a next generation of satellites. So there's always we will uncover things that we didn't expect, but our planning assumption is that we'll go operational in about a year.
Thank you very much. And we have an additional question that we've received in writing from a journalist who unfortunately had to leave and will listen to the recording. It's a question from Marta Melli of Sky Telegiornale. She asks, what is the estimated duration of the mission, and is there a possibility for an extension? Thank you.
I can respond on the first part, maybe Phil. It's, we have planned continuity of data for the next 22 years.
So yeah, it's exactly as Simonetta said. But a lot depends on, well, whether the hardware in the space segment operates well and there are no faults, and generally it does. And then you are limited by fuel for station keeping measures. So certainly with the previous METOP satellites, they've exceeded the planned lifetime. So with careful management from our operational teams and preserving fuel usage, remembering that we're keeping about 2/3 of the fuel usage spare to deorbit the satellite, we would hopefully expect the lifetime to be longer than that. The planning assumption, as Simonetta rightly said, is 22 years.
Thank you very much. We've received a question from Ulrike Ebner of Flugreview. Ulrike, you should be able to unmute, otherwise I will read the question for you. I'll read the question for you as I see that you are not unmuting. Why did you choose the architecture of successive pairs of satellites? What are the advantages?
Maybe on this one, I let Marc Loiset intervene if he's connected to say exactly the architecture elements of the mission. Marc?
And Marc should be able to join us. I have just, Marc, feel free to put on your camera if you can, and you can certainly, there we are. Thank you very much, Marc. And you are still muted, Marc. There we go. You are now unmuted, and thank you very much for joining us. If you can introduce yourself as well, if you don't mind, for those that have joined us a little bit late. Thank you.
Yes, can you hear me? Okay. Yeah, thank you very much. So I am Marc Loiselet, and I am the project manager on ESA side of the METOP-SG. So why do we have two satellites? Is because the first satellite. Sorry, I've got some echo.
We can hear you clearly, Marc. So feel free to explain to us why we need successive pairs of satellites. Thank you.
I've got some echo, but so the first yes. So the first satellite was made of 10 instruments, 10 small instruments. But now with the second generation, let's say, as said by Met Office, there is a need for more data in order to better understand the weather, to improve the weather forecast and to better understand the climate monitoring. So that's why we have now 10 instruments. And because we want better performance and better accuracy, the instruments are bigger. So those instruments being bigger, they cannot all fit in one satellite. So now we have got two big satellites of 4 tons. So grosso modo, the mission from METOP first generation to second generation has doubled, and it had to double on 2 satellites.
Thank you very much, Marc, and thank you for bearing with us while you're having audio issues. I see we have a question from Peter de Selding. Peter, you should be able to unmute yourself. I've just sent you a prompt, and you are unmuted. Thank you.
Good. Can you hear me? Okay, good, thanks. A couple of questions. First for Simonetta. I hate doing math in public, Simonetta, so could you help me with the inflation adjustment going from 2014 to 2024 that gets you to the 2.8 from the 1.3? A lot's happened since 2014, COVID, Ukraine, going from Soyuz to Ariane 6, a lot of moving parts in what might have increased the cost of the mission. It's about 2 or 3 years late. Could you help me unpack on that? For Phil Evans, and also maybe for UK Met Office. Phil, could you give us just a brief protein pill on where you think you are with NOAA now? There's been a lot of choppy waters since January, in the last 3 months particularly. I saw from the UK Met pie graph that it's very nice, the 24% from METOP, 19% comes from NOAA. I'm wondering about the fragility of that figure. And so maybe, Phil, if you could just give it a sense of where you think we are now. And for CNES, people have been applauding IASI for many, many years. It's really, its value is no longer needs to be proven. I'm wondering, has CNES or industry been able to sell that instrument to some other meteorological agency around the world, or is that just not done? And a last question, I think this satellite's one of the ones that has to be deorbited. So you're going down from 800 to a splashdown somewhere. I'm presuming you don't think it's all going to disintegrate, and that it's got to be a controlled reentry into some place. Could you give us an idea, since we're now talking about the EU Space Act and that sort of stuff, how much fuel will be used in that maneuver? That's fuel that could be used to extend the life of the satellite, but how much fuel just is required that you set aside to ensure a controlled descent? Thank you.
And thank you very much. We'll try and take this in order, but bear in mind we are quite close to the end of the session. So
there are lots of questions. I'll start briefly. So 5.2 billion euros, the total cost of the program mentioned by Phil, with about 20% ESA contribution, 80% Eumetsat, and not taking into account the in-kind contribution of the instruments IASI and DLR METimage. On the satellite side, 2.8 billion, 6 satellites at this 2025 current economic condition. These are the costs. And for the fuel, I mentioned 2/3 of the fuel will be actually used for the controlled reentry. And I'm sure that Phil or others want to comment on this.
Perhaps I can pick up on the relationship with the US. So, of course, as under the current administration, as it's addressing its policy priorities, we're of course paying careful attention to what those might mean for us. I'm sort of pleased to say we actually fairly soon into the start of the new administration, we had a high-level bilateral meeting with NOAA NESDIS, and we've had further meetings with them, including at a very high level. I think things are pretty secure, I would say, and that's basically because we have a long-standing partnership that is mutually beneficial to both parties. The US gain a lot from this collaboration. Europe gains a lot from this collaboration. So it's solid because of the mutual benefit. So I'm fairly confident about how things will progress, and that's certainly the signals we've got from the US.
Yeah, I'll just add to Phil's point. I think weather has no boundaries. The atmosphere has no boundaries. Like across the international community, I think there is good conversations held by Eumetsat around what satellite launches are going to happen, who's investing in what technology, and how does that support the kind of international endeavour, both from a weather and a number of other applications which are important for the world.
Thank you very much. And I don't know, there was a question with regards to IASI, the instruments from CNES. Selma, would you like to?
Yeah. Thank you very much. I will take over. Before responding, I would like also to enhance the fact that the CNES has funded the IASI-NG development with the half contribution from Eumetsat. Roughly, it represents 400 million euros full cost. Half of this has been funded by CNES. It's important, of course, to add the overall budget has been presented previously. Regarding the fact that if the industry or CNES has also sold the equivalent or the IASI instrument at the export, no, not like this instrument, but of course the know-how of the expertise around this sounding, infrared sounding expertise, of course, is often highlighted within the international cooperation, mainly through the science expertise and also CNES technical expertise in terms of data accuracy and quality and performance. Thank you.
Thank you very much, Selma. I noticed that we have quite a lot of questions still, and we are unfortunately out of time. I want to thank both Marc Loiselet and Didier Martin, who are both already answering some of your questions. We've taken note of them, and I will get back to you together with my colleagues after this media briefing so we can provide you with answers, because we are running out of time. I want to thank our panelists and the journalists for making the time to talk about these exciting missions today. And please, if you have any other further questions, email media@esa.int. I'll be sure to put you in touch with the right entities and the right spokespersons. Thank you all very much for your time, and go METOP, go Sentinel-5, and go Ariane 6. Have a good afternoon. Bye-bye.
Thank you very much.